In this video, we'll talk about calculus in polar coordinates. So if we start with the equation r equals f of theta in parametric form with theta as a parameter, we know that x equals r cosine theta, and if we replace r with f of theta, we get equals f of theta cosine theta, and y being equal to f of theta sine theta. If we want to find the dy dx, the slope of the tangent line is going to be y prime of theta over x prime of theta. So dy d theta over dx d theta. And if we differentiate y, which is f of x sine of theta, f of theta sine of theta, if we differentiate it using product rule, we get f prime sine theta plus f of theta times cosine theta. And similarly, if we differentiate x, we get f prime cosine theta plus f of theta cosine theta prime, which makes it negative f of theta sine theta. Now, if it's given that the graph passes through the origin for some angle theta of 0, so then the equation above simplifies to dy dx. So this equation, which we use to differentiate to find the slope, becomes sine of theta 0 over cosine theta naught equals tangent of theta naught, where f prime of theta naught cannot be 0. Let's solve the example. Find the slope of the line tangent to the following polar curves at the given point. So r equals 1 minus sine theta. So that means f of theta is 1 minus sine theta. F prime of theta is equal to negative cosine theta. And we want to find out dy dx. So using the formula above, the highlighted one and labeled with 1, we have f prime of theta sine theta plus f of theta cosine theta over f prime of theta cosine theta minus f of theta sine theta. So if we substitute, f prime theta is negative cosine theta, so negative cosine theta sine theta plus f of theta, that's 1 minus sine theta cosine theta, over f prime of theta, negative cosine theta times cosine theta, that's cosine squared of theta, minus 1 minus sine theta times sine theta. So let's simplify it a little bit. So we get negative cosine theta sine theta plus cosine theta minus sine theta cosine theta over negative cosine squared of theta minus sine theta plus sine squared of theta. So the numerator, these two, so we have cosine theta, and those two are negative 2 sine theta cosine theta, and the denominator is negative sine theta, and these two are minus cosine squared of theta minus sine squared of theta. So we get cosine theta minus, this is a trigonometric formula, it is equal to sine of 2 theta, and the denominator is negative sine theta minus, and this is another trigonometric formula, that's cosine of 2 theta. So if I want to evaluate dy dx for theta equals pi over 6, we get cosine of pi over 6 minus sine of pi over 3 over minus sine of pi over 6 minus cosine of pi over 3, right? Because 2 times pi over 6 is pi over 3. So cosine of pi over 6 is cosine of 30 degrees, so that's square root of 3 over 2, minus sine of 60 degrees, that's square root of 3 over 2. The denominator, negative sine of 30 degrees, that's 1 over 2, minus cosine of 60 degrees, that's 1 over 2. So the numerator is 0 and the denominator is negative 1. So the answer is 0. So the slope of the tangent line at 1 over 2 pi over 6 is 0. Let's solve another problem. Find the points at which the polar curves have a horizontal or a vertical line tangent. So let's start by writing f of theta is equal to 4 cosine theta, which means f prime of theta is equal to negative 4 sine theta. Since we are talking about horizontal and vertical line tangents, tangent lines, we are thinking of finding the derivative and going from there. So we want to find the slope. dy dx is given by f prime of theta sine theta plus f of theta cosine theta over f prime theta cosine theta minus f of theta sine theta. Cosine of 2 theta equals 0 means 2 theta equals pi over 2, or 2 theta equals 3 pi over 2. That's where cosine of 2 theta equals 0. So that means theta equals pi over 4, which means r equals 4 cosine pi over 4. It's 4 times square root of 2 over 2, which is 2 square root of 2. So the point where the horizontal tangent line, where the line is, the tangent line is horizontal, it's 2 square root of 2 and pi over 4. And the second point, theta equals 3 pi over 4. So r equals 4 cosine of 3 pi over 4, which is equal to 4 times, well, 3 pi over 4 is 45 times 3. That's 135. So it would be around here. So pi over 4 is the reference angle. So it's going to be negative square root of 2 over 2, which is negative 2 square root of 2. So the actual point would be negative 2 square root of 2, 3 pi over 4. So these are the 2 points where the tangent line, it's a horizontal line. Now let's talk about vertical tangent line. So we go back to the result we got for dy dx for the slope. So we get sine of 2 theta equals 0, which means 2 theta equals 0, or 2 theta equals pi. So theta equals 0 means r equals 4 cosine 0, which is 4. So the point is 4, 0. And then theta equals pi over 2, which means r equals 4 cosine of pi over 2, which is 0. So the point is 0, pi over 2. So in conclusion, the 2 points in the polar coordinates where the tangent line is vertical to the graph, it's 4, 0 and 0 pi over 2. Let's talk about the area of regions in polar coordinates. So let R be a region bounded by the graph of R equals f of theta and R equals g of theta. Between theta is alpha and theta equals beta, where f and g are continuous and f of theta is greater than or equal to g of theta greater than or equal to 0 on alpha beta closed interval. The area is given by integral from alpha to beta of 1/2 f prime of theta minus g prime of theta d theta. Really quick, where is this area, or where is this integral coming from? Well, let's remember that if I want to find out the area of a slice of a circle, then we are going to say, and then this is like delta theta. So it's an angle, right? And this is the radius. Then the area of the slice, it's equal to delta theta over 2 pi. So of a circle, delta theta over 2 pi of the area of a circle of pi r squared. So pi and pi cancel, so we get 1 over 2 r squared delta theta, right? So if you think about an graph that looks like this and we want to find out the area, we split it in these slices, right? So if we split it between an angle of beta and an angle of alpha, right? Theta equals, like, let's say this is theta equals alpha, and let's say this one theta equals beta, and I want to find out this area between these two. Then we are going to add, I remember from Calc 2, we are going to add all these slices, right? And we set that delta theta to approach 0, so these to be really tiny angles. So that makes it the area to be 1/2. So 1/2 is coming from here. Then delta theta is this d theta, which makes it a very small distance. And then r squared is given by a function of theta, and it's squared. So in this problem, let's figure out what we have. Well, because we have only one function, then we are going to say f of theta equals square root of cosine theta. So we want to find the area of the region inside the curve r equals square root of cosine theta. So area, it's equal to integral from alpha to beta of 1/2 square root of cosine theta squared d theta. But it's important to figure out what we should put as our limits of integration. So let's make a quick sketch, and I'm going to use the calculator, and to see how does the graph look like. So if we go to y equals and we put square root of cosine theta, and then we press graph. Well, if you cannot see it very well, don't forget to press zoom 0. But here it's pretty clear that this is the graph. So this tells me that I have the integral can be calculated from, so the angle 0 to pi over 2 is going to give me this half of the area. So going back, I'm going to say integral from 0 to pi over 2, and that's going to give me 1/2 integral from 0 to pi over 2 cosine theta d theta. That's 1/2 integral of cosine theta, it's sine theta, from 0 to pi over 2. That is equal to 1 over 2 sine of pi over 2 minus sine of 0. Oops, 0. So we get 1 over 2 times 1, which is 1/2. So again, all we found was the area above. So we are going to multiply by 2. So the final area is 1/2 times 2, which is 1. All right. So let's solve this problem. Find the area of the region inside the curve r equals square root of cosine theta and inside the circle r equals 1 over square root of 2 in the first quadrant. So let's remember that this is how the graph looks like for square root of cosine theta. So I'm going to graph it, because if we have a picture of what we want to find, it's much easier to solve it. So the first one, the square root of cosine theta, looks, so it goes from, if theta is 0, we get 1, the radius, and then, so it looks something like this. So it went all the way to 1. Now this circle r equals 1 over square root of 2, it's x squared plus y squared equals 1 over 2. So basically it's a unit circle with the radius square root of 2 over 2, right? Square root of 1 over square root of 2 is square root of 2 over 2, which is approximately 0.7. So basically, if this is 0.7, 0.7, then this would be the circle that you are looking for. So the area that we are looking for is this area. So if I split it like this, then I would have to add 2 areas. I would have to add this area and this area, area 2. So let's see. Where does, or what is this angle theta here? So square root of cosine theta, where does that equal the 1 over square root of 2? So cosine theta equals 1/2. It means theta equals pi over 3. So in other words, the area is the integral from 0 to pi over 3 of the red one. So the red one is the 1 over, so it's 1 over 2, and then is 1 over square root of 2 squared, and then d theta plus integral from pi over 3 to pi over 2 of 1 over 2, and then square root of cosine theta squared d theta. So let's compute this. We get 1 over 2, and then 1 over 2 theta from 0 to pi over 3, and then plus 1 over 2 integral of cosine theta, that's sine theta, from pi over 3 to pi over 2. So if we compute, we get 1 over 4 times pi over 3 plus 1 over 2, and then sine of pi over 2, which is 1, minus sine of pi over 3, which is square root of 3 over 2. So we get pi over 12 plus 1/4 we can write. If I put this 2 over 2 and factor out a 2, it's going to be 1/4, 2 minus square root of 3, and we found the area. And let's talk about the arc length of a polar curve. So let f have a continuous derivative on the interval alpha beta. The arc length of the curve is given by integral from alpha to beta of square root of f squared of theta plus f prime squared, f prime of theta squared d theta. D theta is outside of the radical. So let's solve the problem. Find the arc length of the spiral r equals f of theta equals theta for theta between 0 and 2 pi. So L equals integral from 0 to 2 pi. F of theta in this problem is theta, and f prime of theta equals 1. So we have square root of theta squared plus 1 d theta. So we want to calculate this integral. So let's calculate the integral. So what we'll do is we're going to use trigonometric substitution. So instead of theta, we are going to use tangent of x. So d theta equals secant squared of x dx. So the integral becomes integral. I'm going to leave the limits of integration for now. So it's going to be square root of tangent squared of x plus 1 times secant squared of x dx. So that is equal to square root of tangent squared of x plus 1 is secant squared of x times secant squared of x dx. So this equals to integral of secant of x times secant squared of x dx equals. So let's use integration by parts. So we'll say integral of secant of x times secant squared of x is tangent of x prime. So using integration by parts, this equals to secant of x tangent of x minus integral of secant of x prime. Well, secant of x prime, it's 1 over cosine of x prime, which makes it sine of x over cosine squared of x, which is tangent of x times secant of x. So it's tangent of x times secant of x times tangent of x dx. So equals secant of x tangent of x minus integral of tangent of x times tangent of x is tangent squared of x times secant of x dx. So that equals to secant of x times tangent of x minus integral of tangent squared of x is secant squared of x minus 1 secant of x dx. So this equals to secant of x tangent of x minus integral of secant cubed of x dx plus integral of secant of x dx. Let's not forget we started here with integral of secant cubed of x, right? And we ended up with having integral of secant cube of x as well. So we're going to say I, the integral that I wanted to find, it's secant of x tangent of x minus I, right, the same integral, plus integral of secant of x, it's ln of absolute value of secant of x plus tangent of x. So if we add I to both sides, we get 2I equals secant of x tangent of x plus ln of absolute value of secant of x plus tangent of x. But let's not forget that tangent of x is theta. So we want to go back to our limits of integration, which were 2 pi and 0. So tangent of x equals theta means that, let's say, what would be sine of x, for example. So tangent of x means the opposite. So this is x. So the opposite over adjacent. So then theta over 1. So the hypotenuse would be theta squared plus 1. So secant of x is 1 over cosine of x, which means 1 over cosine of x is adjacent over hypotenuse. So secant of x is square root of theta squared plus 1. Tangent of x, we know it. So I equals 1/2 secant of x, so square root of theta squared plus 1, times tangent of x, which is theta, plus ln of absolute value of square root of theta squared plus 1 plus theta. Great. So now we are evaluating this from 0 to 2 pi. So then we get the integral that we wanted to find. It's 1/2 times 2 pi square root of 4 pi squared plus 1. Then minus and replace theta with 0. That's going to give us 0 plus ln of square root of 4 pi squared plus 1 plus 2 pi minus ln of 1, which is 0. So this is the answer. Well, these two also cancel. So I equals pi square root of 4 pi squared plus 1 plus ln of square root of 4 pi squared plus 1 plus 2 pi. So this would be the answer for our integral. So for our arc length.